In this first video, I want to talk to you about bar charts. I'm here in my Jupyter notebook inside of Microsoft Edge, my web browser. I have navigated to the folder that contains the files that I want to work with, and in my case it's in my OneDrive file. I've created a folder called YouTube, and inside of that a data visualization with Plotly for Python. I have a style sheet, a cascading style sheet that will be uploaded to GitHub so that you can use that as well. I have a Python cheat sheet, a PDF, which I'll also download. You can get that from the Plotly website. There's a style template, which I just always save just to open up, and it's got the bare bones of which I want to work with. But here's the file we're looking for, the simple bar chart. Let's open that up. And there you go, everything is ready. You'll see the first cell that I have here is just the import of the cascading style sheet. It's ipython.core.display, and from that I import HTML. I reference the file, this cascading style sheet file, and that lives in the same folder as this notebook, and I just use the HTML function there, open the CSS file in read mode, and we read it. And if I execute that, you'd see that I have this new style. I have my H1 color of the text here being blue, the H2 being this nice orange, etc. Just styles the notebook for me. So let's have a look at the simple bar chart. Now, first of all, I want to set up my Plotly library. And what we're going to use here is called notebook mode. So I don't want to have these files uploaded to the Plotly website to live in the cloud. I just want to use them locally, so I'm going to use the notebook mode. So from plotly.offline, I'm going to import iplot and init notebook mode, as you can see here, and I'm just going to call this function init notebook mode. So if we run this, that'll just import this iplot and initializing this notebook mode, and it'll initialize this notebook mode. So what do we actually want to import from Plotly? Well, we're going to start off with these high-level charts. So bar charts, scatter charts, etc. These are high-level, and I can just use them as is. So I can say import plotly.graph objects, so graph underscore objs as go. Let's do that. So let's start off with a very bare bones chart. The first thing we want to set up is just what is called the trace. We call it trace here as just a computer variable, but that just creates on top of the figure that we are creating, this blank figure, we're going to put on these elements, and it's just the norm or to call them trace. So go, remember that's my graph objects dot bar. So immediately the arguments here are specifically for a bar chart. That's why we call this high level chart. I don't have to design every single little element. Most of it's already designed inside of this bar object, and I just have to pass some arguments to it. And I'm going to pass x arguments for the x-axis and y arguments for the y-axis. So what is a bar chart for? A bar chart is for categorical variables. So anything that is not necessarily a number, although numbers can also be categorical variables, but they are not numerical, and as such as the difference between them are not set and standard. So I could call January, February, March 1, 2, and 3 for the first, second, and third months of the year, but that does not make them numerical variables. They are still in that instance categorical variables. So bar charts are for categorical variables. So my x-axis here, I'm going to have the categories January, February, and March. And on my y-axis, I'm going to have numerical values. So how many things, whatever the situation might be. In my instance here, I'm going to use, you'll see later on, I'm going to call them sales. So in January, there were 10 unit sales, in February 11, and in March 14. So those are numerical values on the y-axis, categorical variables on the x-axis. Now I'm going to introduce a second computer variable. I'm going to call it data, and I'm going to pass into that a list. So it goes inside of square brackets. I'm going to pass a list of all the traces. These are these elements that go on top of my blank figure. And in this case, I only have one trace, but I've got to put that inside of these square brackets. I'm referencing trace here as a list element, an element inside of this list. Third computer variable that I use here is this fig. Now these are just standard. They're used in Plotly all the time, so might as well stick with those. And I'm going to call another graph object called a figure. That's a blank canvas, a blank figure. And figure, with a capital F, as you can see there, it takes a couple of arguments. In this instance, we're only going to use one argument, and that's the data argument, as you can see here. And we're going to set that equal to data, which is this data, which contains a list of trace, and the trace is a bar. So it just builds one thing on top of the other. So inside of this data that I'm referencing, there's a list, and the first element in the list is trace, and in trace is this element called a bar chart. Finally, I'm going to call iplot, remember, which we imported up here. iplot, that's for plotting directly in the notebook, not using online mode, so not going to the cloud, and I'm going to plot this figure, F-I-G, fig that I've created. Let's hold down Shift and hit Enter or Return, and there you go, your first very beautiful Plotly chart. So again, we can see the x-axis here, January, February, March, and we can see the y-axis, the values that we put in, 10, 11, and 14. Now I'm going to use my mouse on the left-hand side. Look what happens when I hover over the text, over this element, the elements on this blank figure. So the go.figure was this blank background, and I put these elements on top of it, which is on a high level was a bar chart. I hover over it, and you see that January at the bottom it gets highlighted, and the number 10 at the top gets highlighted. That's very nice. I really like that, because if I give a presentation, and I don't use PowerPoint for presentations, I'm not a PowerPoint user or fan. Well, I mean, you've got to use it sometime, but I try to stick with my Jupyter notebooks, and it's very nice to have this interactive plots as you do your presentations. And look what happened at the top here as well. I get quite a few little buttons here to press, and that I really find very useful, because I can download this plot as a PNG file directly on my hard drive, and I can put that inside of a hard copy if I were writing a report and it's got to go inside of a Word document, etc. I can just do that. I can save this for editing in Chart Studio. That's online in your Plotly online account. You can zoom, you can pan, you can select a box, and we're going to see all of these because they become very useful. I can zoom in, I can zoom out, and out even further, and out even further. I can just go back home, and that just resets everything for me. I can show the closest data on hover. So if I do this, you're only going to see January being 10, February 11, March 14. And if I click that, you see the highlight happens at the bottom on the x-axis instead of on top at the top there. And then I can just open Plotly, the website itself. So very nice, especially this download as PNG file. So that is fantastic. So let's add a little title, because you can see at the top my chart has no title. So I'm going to introduce a new variable called layout, and this layout is going to be a Python dictionary. So it goes inside of curly braces, and it has the key value pair. So the key colon the value. The key is title, and these go inside of quotation marks. So the title, that's the key, and the value for the dictionary for this key is sales for first quarter. Now I'm going to redo my fig from up here. It's still going to have the trace, it's still going to have the data. All I'm changing is this fig. So go.figure, the data still is the data from our first one, but the layout is now this dictionary called layout. So this data and layout, these are the argument names and the argument values. Well, we gave the computer variables exactly the same name. Don't worry, there won't be any confusion for Python. It'll understand, and Plotly, this Plotly figure will understand what's going on. So data just refers to the data that I created with a trace list, and layout, this layout refers to this layout. So let's plot this, Shift Enter, Shift Return, and now at the top I have sales for first quarter. So a beautiful title now on the top of my figure. What about some axis labels? Now, with these categories that we put in January, February, March, it's easy to see that these are months, but I might want to specify that. And more importantly, I want to specify what's on this y-axis, because what is 1, 2, 3, 4? You need to know what these are. So I'm going to just change my layout computer variable. Still going to be a Python dictionary. Title is still going to be first quarter elements. Now the x-axis, that's the key, it holds a value, but the value is another dictionary, and that dictionary is again a key and value pair. So the title is going to be months, and the same for y-axis. The key is y-axis, the value is another dictionary, and that dictionary contains a key value pair, the key being title and the value being units. Now I'm going to do something different. Remember up here, we just said data equals data and layout equals layout, but we're going to do something a bit different here. So instead of creating a blank figure, I'm just going to pass everything as a Python Python dictionary. So here we have iplot, and inside of that there's this dictionary. And the dictionary is just a key value pair, comma, another key value pair. So data is just data, still the data from upstairs, and the layout is just this new layout. So let's shift and enter, shift and return, and now we can see that we have months here as our x-axis title and units as our y-axis title. So that's how many units were sold in January, February, and March. So see the difference here between the two. So I did not invoke the figure, the go.figure object here. I just passed everything to iplot as a dictionary. And sometimes it gets confusing because there's many ways in Plotly to do something. You'll see more ways as we carry on. So when it comes to the layout and such, I try to stick with these, just to stick with the Python dictionaries. When you stick with the dictionaries, it becomes slightly less confusing, and you can find something that's just stuck in your mind and it works for you, and just carry on with that. So I like just to use for layout and then plotting just this dictionary way of doing things, although you don't have to stick with that. As we could see here we created this blank figure and we passed these arguments to it, but I can also just use it as pass to iplot, just a dictionary. And as I say, there are many things I can do with this x-axis being a key and the value pair. There are many more things than just a title, and we'll see some of them just in this tutorial. So it lessens the confusion for me, but look at the website, the Plotly website, and you might find other ways, and we'll look at some of these in future videos. But I stick with this, but look what works for you. So let's just rotate these labels at the bottom. January, February, March are quite small here, so they fit in with this big chart that we have here. But sometimes you have long categorical variable names here, data point values here, and we've all seen plots where these names actually start printing on top of each other. And the easiest way to get rid of that is obviously to shorten the data point values, your sample space values. But sometimes it's not possible, and you just want to rotate them. And look at this, and that's a reason why I like these dictionaries, because look at this. I have layout again, which is a dictionary, key value pair. Here's another key value pair. But now I have two elements here in this value side of the x-axis being the key and the value being another dictionary. And inside of that dictionary there are two key value pairs. Title is months, and the tick angle is -20. I don't put that inside of quotation marks because it's not, this is just a value, numerical value. So I'm going to say -20, and that rotates it -20 degrees. And my y-axis is still all the same. So let's run that. And if we scroll down, we see we have this -20 degree from the horizontal. It's tilted down -20 degrees. So if you have these long words and sentences there, they can all fit in because of that angle. Now let's color these bars. The blue is fantastic. I like this color, but you are free to do what you want. So I'm going to just change my trace here. It's still a bar, high-level bar chart. I still have the x-axis values being categorical, January, February, March. I still have my y values being numerical, 10, 11, 14. But now I'm going to change the marker. I'm going to introduce this marker. And again, it's a dictionary, but this is another way just to do a dictionary. So I'm going to call this dict here. And the first thing I want to pass is color, and the color is going to be a list. And this list refers to the elements as you pass them on the x-axis. So I have 1, 2, 3 elements, January, February, March. I've got to pass 3 colors here. And I'm going to use this format. Note that I have these quotation marks. They can be single or double. They're single in this instance. But it's RGBA. RGBA means I can also pass a fourth value here, which would be transparency. 0 being fully transparent, 1 being completely opaque, and anything in between. So it's red, green, and blue channel, and then opacity. So RGBA, and then parentheses 255, that's maximum on the red, 0 for blue, green, and 0 for blue, and full opaqueness. So value of 1 there. The second one is 204, 204, 204. So that's going to be this light gray, and it's going to be totally opaque, and again totally opaque. So January is going to be this red color, and March and April is going to be this light gray color. And the data is still the trace. Now I can't just use the ones I used up before because data referred to a different trace, and I've changed the trace here, so I've just got to do data equals trace again as a list element. And then the layout exactly the same, and I'm passing this dictionary to iPlot. Nothing new there. And now you can see these beautiful colors because I can now have January being this red and the other colors being this light gray. Fantastic. Now, why is this one red and these ones gray? Well, I might want to indicate to my audience why this was done, so I can actually change this hover text. Remember, if I hit this 1, show closest data on hover, it's going to do both the x-axis and y-axis in one little tooltip there, January, or hover text there, January 10, and if I do that, it's just going to highlight them separately. Now, hover text means I can individualize every element that I hover over to have its own text. So we've had marker, we've seen that, so I'm introducing a new argument here to the bar here, text, and I've got to do it individually. So the red one's going to be below target, above target, and above target. Everything else is the same. Let's run that. And now if I hover, I see this extra text appear in this hover. So that was, I put it 10, and that's below target, and that one was above target, and that one is above target. So you can see you can build in this beautiful narrative here because you can put a lot of information in this text if you really want to draw attention to what's happening here to inform your audience. So that's fantastic. So let's move things up just with a grouped bar chart. And now I want to have two sets of elements on here. And so I've changed my computer variable to trace 0 and trace 1. And with a bar chart, be careful now because we want the same sort of space for both. So I've got January, February, March, and January, February, March. And I've got my Y values 10, 11, 14 as before, and the second Y is 12, 13, 17. But now I'm going to add a name because I need to tell Plotly that these two things are separate. So I'm going to say name equals last year, and this name equals this year. So you can well imagine that I'm just going to take this year's data and compare it to last year's data. That might be interesting. And now look how data has changed. I'm now passing two elements to this list. Still got to be a list, still inside of square brackets. So I've got trace 0 and trace 1. The layout is going to be exactly the same, but I'm introducing this new key value pair of bar mode, and the bar mode that I want you to use here is group. So what it's going to do, it's going to group January and January, February and February, March and March. Hence they've got to be the same. And then I'm still going to use this dictionary to pass to iPlot, and now they've been grouped. And we see last year in blue and this year in orange. That will be the default colors, and you see that they are indeed grouped. So I've got this year and last year, this year and last year, this year and last year. A beautiful way just to do that. Now we needn't group them like this, we can stack them as well. And here I have exactly the same thing, but instead of bar mode being group, I've made bar mode being stacked as the key value pair here. And if we run that, we see that we now have this stacked version of it. But if I hover, you can still see that this year is 12 and last year was 10. You don't have to go to the x-axis in your mind, and your audience have to mentally try and see where's that top and subtract from the 10 to see that it actually gets to 12. No, Plotly makes it brilliantly easy. With your hover, you can give a beautiful presentation just to hover over these and explain. So that's our first tutorial on Plotly, my all-time favorite library for plotting inside of Python, but inside of other languages as well. And a nice introduction for you. Start playing with this, and we'll carry on with this playlist on YouTube, and I'll introduce you to a lot more plotting using Plotly for Python. Before you do go there, please subscribe to this channel for all the information that I'm trying to get you. Hit that notification button, the little bell there, to let you know when new videos are uploaded. Thanks a lot. My name is Jean Klopper, and I'm a surgeon at Groote Hospital and senior lecturer at the University of Cape Town. Now I run the Klopper Research Group, where I really support our postgraduate students in their research. My main field of research is machine learning in the clinical setting. In the support of research, I have a lot of online courses here on YouTube, but also on Udemy and the massive open online course platform Coursera, where I really teach biostatistics. It's what it's all about. Now, when we use Python locally, one of my favorite plotting libraries is Plotly. You can do Plotly online, but you can also use it in Python and many other computer languages as well. So this whole series is going to be about Plotly, and I'm going to start off by just showing you the basics, and the easiest way to get going is through a bar chart. So subscribe to this channel, hit that notification button. Every time a new lecture comes out, a new tutorial comes out, you'll be notified about it. So please do that. Let's watch this first video on bar charts. So in today's tutorial, we're going to talk about the humble histogram. So in my first cell here in my Jupyter notebook, I'm just importing my cascading style sheet as per usual, just to get away from this bland looking black to just something a bit more interesting. There we go. If I run the cell, we see these nice little colors and different fonts for the markdown that is used. So let's set up the library. I'm going to import from plotly.offline my iPlot so that I can plot directly in this Jupyter notebook, and to the init notebook mode just to initialize the notebook. We did that with the previous tutorial on the bar chart. We're going to do exactly the same here. And again, we're going to make use of one of the high level charts. So we're going to do plotly.graphObjects as GO. We'll do that import as well. Now for this case, I just want to generate some random values. So I'm going to import the random module, the Python random module. So that's very easy, import random. And I also want to import the numerical Python library, NumPy. And I'm going to use this namespace abbreviation. So I'm going to say import NumPy as NP. Now I'm going to just seed this pseudo-random number generator so that we get the same results every time we generate these random values. And I'm just going to seed it with a value 1, 2, 3, 4. And there we go. So let's create a few random values. My first variable here is called age. And I'm going to just use a uniform distribution. So I'm going to say np for numpy.random. So I'm doing the random module in this NumPy library. And from there, I want the uniform distribution. My lowest value must be 21. My highest value is 75. And the last argument here is size, meaning I want 100 values from that distribution. The next one, I'm just going to use the computer variable salary. Again, that's numpy.random, and this time from a normal distribution. I want the mean, which has the argument LOC, to be 3000. I want the standard deviation, which is the scale argument here, to be 1000. And again, the size, the number of samples I want drawn being 100. Now I'm just going to use a choice between, just purely for the sake of simplicity, use a gender, a binary gender here, just purely for the sake of simplicity. And I'm going to create the computer variable binary gender. And I'm going to use from the random module, I'm going to use random.choices. And what you can do with this choices function is just to pass a list of all these various text, the string elements that you want to choose from. So I've got female, then male, and I'm going to say draw at random 100 of those. And it is drawing that at random with replacement. So the first one might be female, it puts female back in the box, draws another one blindly out of the box, that might be female again, throw it back. So 100 of those choices. Now I want to place these inside of a pandas data frame. It's a beautiful thing to use. I urge you to have a look at pandas. I'm going to import pandas and use the abbreviation PD. And I'm doing that because I want to create a data frame. I'm going to call my data frame df, and I'm going to call the data frame function here pd.dataframe, and I'm going to create this data frame out of using a dictionary. So I'm going to have this age column, and underneath that age column, think of a spreadsheet. So the header, in the first row, I have my header values, my variables, and I'm going to call this first one age. And down that column, all the rows are going to be populated by these 100 age values. The salary is going to be the next column header in my spreadsheet, basically, which was what a data frame can be seen as in a simplistic way. pass all the 100 salary values, and then gender, this binary gender values of mine. So let's run that, and I've created a data frame. And I'm going to split my data frame in two, one for female and one for male. And the one that we're going to do, the way we're going to do that, create these two computer variables, female and male. The first one says take this data frame, and then we're going to use this square bracket notation because it wants to run down row by row. So I'm just indexing this df.gender column. So it's going to look down the gender column and only select those. So this is a Boolean double equal sign, only the females. And then male will only be contain the male. So I have two data frames now, female and male. So let's create our first bare bones histogram now that we have some data. Again, per usual, just by convention, I'm going to use this trace computer variable, and it's go because this was a graph object, one of the high level graph objects, and it's a histogram. I'm going to pass it the x value because let's just stop there for a moment. Just to discuss what a histogram is. Whereas a bar chart looked at categorical variables on the x-axis, the histogram is going to look at numerical variables. So age is definitely a numerical variable, a ratio type numerical variable because there's a true zero. And we're going to split that up into little bins. And if we just pass the age here, Plotly will decide how large those bins are. So what are bins? Well, as soon as I show you the histogram, I can show you what bins are. Again, the computer variable data, and pass the list of all these histogram elements I want to put on my figure. And then instead of using go.figure, I'm just going to use this dictionary notation. So I plot and then data, please. And we see here, look at the bottom. These are numerical variables. It's not categorical. And what it's done is it seems to be having plot from 20 to 25, 25 to 30, 30 to 35, 35 to 40. And that's what I mean by these little bins. So all it's going to do, it takes those 100 values and it decides how many are between 20 and 25. And it'll count them, and it noted that there was 8. And between 25 and 30, there was 30. Between 30 and 35, there was 5. Between 25 and 30, there was 8, etc. And so it goes on. So that is why a histogram is not a bar chart. And what you can see here also, there is really no spaces between these. Just to indicate that we're talking about a continuity here, whereas a bar chart, by definition, has these gaps in, just to create this visual impression that we are dealing with categorical variables, that this is not a continuum. And here we do have a continuous random variable at the bottom called age. Now let's just change that to a frequency distribution, or otherwise known as the normalized histogram, because what you can see on the top one here is we count. We count how many were between 20 and 25. But if we normalize that, it gives us a frequency distribution. And the way that we do that is just by, in this histogram element that we create at the top, we pass a new argument, histnorm, and we pass to it this equals probability. I'm going to introduce a layout here by a dictionary format. So I have title and its frequency distribution of the age variable, and my x-axis I'm going to bring in a title, also a dictionary with a key value pair, the value pair being a dictionary itself consisting of a key and a value, and my I plot via a dictionary as well. And now we can see frequency distribution of age. I have age in 5-year increments here at the bottom, but most notably you'll see now this is normalized. So the area under this curve, which is the area of this rectangle and this rectangle and this rectangle and this rectangle, is going to sum up to be 1. It's mutually, these bins are mutually exclusive but collectively exhaustive, so they are all here, and the area under this stepwise curve is going to be 1. So it's a frequency distribution. So I'll have to, if I want to get how many there are, this increment is 5 times 0.08 to get to the value that we have there, well, let's have a look. So that was 8. So remember, these are now units of 1. So 0.08 times 100 is going to give you that 8. So let's create 2 in an overlay fashion. So to do that, I'm going to create 2 traces, by convention calling them trace 0 and trace 1. So go.histogram, and I have x equals female.age, and this time I'm going to give it a name so that we can have this little sidebar that indicates what is what. And the second one that I'm plotting, it's going to layer them from the back to the front. So the back one, is going to be female, the one in front is going to be male. So I just want to lower the opacity of the front one so we can still see the bottom histogram, the bottom trace through that. So I'm going to set opacity equals 0.8. Everything else being the same, I'm bringing in my little layout there. And now we can see I've got two plots here. It's going to give me this little legend on the side. And I've created a bit of opacity here in the orange, which is the male, just so that this female at the back shines through. But if we hover over them, beautiful, it's beautiful what Plotly does, and you can see that it's still going to give you the values. Let's stack them, so I don't have to do the opacity there, and it is just going to stack them, but it's still going to give me these values to say in male there was 4, and in the female there was 12. And look at one thing though, a difference that it made. It is now making these blocks of unit length of 10 years. So I've put in that as 10 years. That didn't influence that this was done. I drew this first and saw by, automatically it chose 10, and I put the 10 in there after the fact. So let's do that. Let's control the bin size. And the way that we do that is by introducing inside of our traces here, we introduce the xbins argument, and I'm going to pass a dictionary for that in this format, not the curly braces format. So start is 20, end at 80. So just the left hand side of the x-axis, the right hand side of the x-axis, and I want a bin size of 5 units. I'm going to do the same for male, and I'm changing my title here to 5 because now I'm in control of it. And if we run this, we'll see that now we are back with this increments of 5. We're back with this increments of 5. Let's just do that again. This time we're just going to stack them, and just for argument's sake, this time I'm looking at female.salary and male.salary, and we have introduced a bin size of 200 here, starting at 500, ending in 5,500. And because we do that from a normal distribution, you can see this tending towards this normal distribution. The last thing I want to show you just in this little tutorial is the cumulative histogram. And when you do statistics and you start looking at cumulative distribution functions, etc., this is important, but we're not dealing with that at the moment. This is just a histogram, and the way that I do that inside of this histogram object that I've created, I'm going to use the argument cumulative and pass to that a dictionary with a key value pair of enabled being true, and I use the dict function instead of the curly braces notation here. And if we just execute that, we see this beautiful stepwise, and we can see the larger steps here, meaning we are dealing with a normal distribution. You can see that from this cumulative distribution function. So that is that for the humble histogram. Remember, that is for numerical variables, and we're just going to start counting them or putting them in a frequency distribution by creating these artificial little bins, and we can control the bin size as I've shown you. So that's the histogram. I'll see you in the next lecture where we continue our look at this wonderful world of Plotly and this wonderful plotting library that Plotly is. Please, please, please remember to subscribe and hit the notification button, because that's going to allow you to know when new videos or new tutorials do come out. I'll see you again. Another tutorial on Plotly using Python. So here we are in a Jupyter notebook. I'm going to execute this first cell as per usual, importing my cascading style sheet so that we have a bit of a better looking notebook here. So distribution plots. Let's start off by just importing our Plotly library. As per usual, I'm importing iplot because I want to plot right inside of my notebook. And I've got to initialize this notebook mode. So let's do that. And then I'm going to import the high-level graph objects as go. So import plotly.graph_objs for objects as go. But something new, I'm also going to import the figure factory as ff. Let's do that. Let's create a bit of data for us for working with in this notebook. So I'm going to import the random module, and I'm going to import NumPy using the abbreviation, the standard abbreviation NP. And I'm also going to seed the pseudo random number generator. So let's create 3 computer variables. I'm going to call them age, salary, and binary gender. So for age, we're going to do a uniform distribution. So np.random.uniform. The low must be 21, the high 75, and I want 1,000 data point values in that uniform distribution in that domain from 21 through 75. Next, the salary I'm taking from a normal distribution, and you see the 3 arguments here. LOC means the mean, scale means the standard deviation, and size just the number of values I want. So from a mean of 3,000 with a standard deviation of 1,000, I want 1,000 data point values from this normal distribution. And lastly, from the random module, we're just going to do random.choices, and purely to keep things easy here and easy to explain at least, we're going to stick with this binary distribution, binary values sample space for my gender variable here. So only female and male, just to make things easy, and 1,000 of those, please. I'm going to import pandas because I just want to create a data frame, and here we have the computer variable df, and I'm going to do a pandas.dataframe, and I created by key value pairs with a Python dictionary. So I have age as my column header, and then the age variable that we created there, salary with salary, and gender with a binary gender. And I'm just going to create 2 sub data frames there. So if we look down the gender column, only include female, and down the gender column only include male. And I'm going to call those sub data frames female and male. So let's run that. And then just let's look at the first 5 rows. So we just call the head function there, female.head, our method there, and we have the first 5 rows. We see the age there, and in the gender column we'll only find females there, and we find the salary column there. So you can see with these pandas data frames, they actually look like just flat spreadsheet kind of files. And let's look at the last 5 rows of the male, and again just to make sure the gender column will only contain males. So let's create our first bare bones distribution plot, and the way that we're going to do that is just create a computer variable called fig, and that is going to be ff for our figure factory there. Dot one of the methods there is the create dist plot, and it takes a couple of arguments. The first one is hist data, and that's the data we want in this distribution plot. Now this distribution plot is going to look like a histogram. It's nothing other than a special kind of histogram. So we've got to give it a list to work with, and what we're going to do is take the whole data frame, go down the salary column, and we say the values in that, and then toList. The toList function there we call on the values of the salary, because we just want to create this list to work with, and you see it is there inside of the square brackets. The group labels, well, we're only going to do one group here, and I'm just going to call it salary distribution. And as with a histogram, we have to have a bin size, and for each we have to have its own bin size, but we only have one here, so in our list we'll only have 200. So that might not make a lot of sense until we actually see what a distribution plot looks like. So let's run that. And there we have our distribution plot. We have the nice histogram down the bottom here, and indeed the bin size is 200. And we also see this kernel estimate here, kernel density estimate, as it tries to draw this distribution line here. And there is our group label. We're only plotting one thing, and that's the salary distribution. So there we go. This is called the rug plot underneath, and each of these little vertical lines is actually one of our salary values. And you can see the distribution. You can also see that we took this from a normal distribution, and you can see the Gaussian type or bell-shaped, at least, that it attempts to take there. So let's just add a title, and we're going to do that by just using one of the ways to do it, at least, and that is just to call fig layout.update. So I've created my figure just as above, and I'm going to update the layout. So just another way of doing it instead of doing it via dictionary as you've seen before. And I'm just going to add a title, and that title is just going to be salary distribution. There we go. We've got a beautiful title up above. So that's not too much fun. Let's just create 2 data sets. So now my hist data, I'm going to make a list of those. So there's just so many ways of doing things in Plotly, and you might find that confusing to start off with, but it also creates a lot of power, and you can find the way that works for you. So here I'm going to take hist data, create a computer variable, and I'm going to pass a list of values. The first list, I'm going to take the female subdata frame, the salary column, the values in that column, and then create a list of that. So the two lists there, and then same for the male. My group labels are now going to be female salary and male salary. And now I'm going to create my fig, and let's create this plot, the hist data. I just passed the hist data there, so I'm not saying hist data equals hist data, because these are just keywords, the normal standard keywords, so we actually don't have to use them. And then group labels is going to be that list. And then my bin size, I want 200 and 200, so the same bin size for each, which means you can make the bin sizes different for each of those. Let's do that iPlot, and now we can see we have male salary in orange there and female salary in this bluish color, and you see the rug plot for each of those. Beautifully done. Let's change the colors of this. So everything exactly the same, but I'm going to bring in a new argument to my create this plot here, and colors I'm going to do an RGB with the opacity here in 0.8 and 0.8 for the opacity. You can see 20, 20, 20, so that's going to be very dark gray, and 150, 150, 150. It's like sort of a middle gray color. Let's run that and have a look, and there we go. You can see the light color for male, the darker color for female there, and because we set the opacity, so you can actually see the one shine through the other. Now, instead of this kernel density estimate plot here, we can actually just use the data that comes out of that and create a mean and a standard deviation, so that we can create this normal distribution instead of this kernel density estimate that we see there. We again have our hist data, our group labels. We create this plot. We have the hist data, the group labels, the bin sizes, but now the curve type is new. It's a new argument, and we're just going to set it to normal. And here's just one other way that we can update this layout or create this layout. So I'm going to call fig.layouts instead of the inverted in the quotation marks and the square brackets. I'm just calling dot layout and dot update, and I'm passing this dictionary to it. So key value pair, the title, fitted. So just another way. It just makes it so powerful and easy to use. You can use whatever way fits you. So now we can see this normal curve that it took from the data, just doing the mean and the standard deviation, so that we can draw this normal distribution here, and you can see the two values there for male and female. So in case you want to omit some things, there's three things here. That's our curve, our histogram, and our rug plot. So we can omit a few things. So we're going to say show histogram as being false and show the rug plot also as false. Everything else exactly the same, except that we've added an x-axis inside of our update to our layout here as a key value pair, the key being x-axis, the value being another dictionary, and that dictionary having two key value pairs, title being salary and the domain being 1000 to 5000. So we can even bring that in, and there we go. We just have these two very nice smooth curves there. So you can see with this distribution plot you can do so much, and you can well imagine some data that will look beautifully if represented with these distribution plots. I'll see you in the next tutorial. Here we are in the next tutorial. We're going to look at the scatter plot. First of all, my cascading style sheet. Let's run that. And we have this notebook that looks a bit better. Scatter plots. Let's set up our Plotly library. As per usual, we're going to import iPlot so that we can plot right inside of the notebook. And we've got to initialize this notebook mode. So we're going to import it, and then we're going to execute that function with these parentheses there. I should say we're also going to import the high-level chart object, so plotly.graphObjects as go, G-O. There we go, indeed. We're going to import the numerical Python library, so NumPy, and we're going to use the abbreviation NP, and then we're going to seed this pseudo number generator. So let's go numpy.random.seed. Let's create a bit of data, some data point values for us to work with. We're going to have 1, 2, 3, 4, and then 5, 6, 7, 8 computer variables here. Female age, male age. So we're going to stick to, just for the sake of ease of explanation, just to this binary way of looking at gender, so only female and male. And we are going to have female So let's create these data points. We're going to have female age and male age. We just, for the sake of ease of explanation here, stick to the binary view of gender. So only female and male. We have the age there, we have salary, and we have debt. So female age is going to be from a random integer with a low of 20, a high of 65, and 100 values. And then the same for males. The salary, we're just going to play a bit. So we're going to take female age, and we're going to add to that a random uniform value from -10 to 10 and add another 1,000. So this is going to be element wise. So for each element in the list of 100 values that we have here in this NumPy array, we're going to add the corresponding value in this uniform value of 100 and add another 1,000. And we're going to do the same to male salary there. And then we're going to have female debt equals male debt. So that's the way to make two computer variables and make them exactly the same as each other. And that's going to be a random integer from 15 to 30 with 100 values. So instead of using the keyword name saying low equals, high equals, because these are normal keywords, you don't actually have to use the names. And so it's 15, 30, 100. And then the tax, we're going to create some of those. And again, just add 10 to each of those values. So let's run that. Let's do a bare bones scatter plot. That's what it's all about. So we're going to go.scatter, scatter being this high level plot that we can use, what is created on top of our figure. And we're going to use x equals female age, y equals female salary. So when you see here with the scatter plot, it's numerical variable against numerical variable. And each one of them will be, each dot that we create in the scatter plot will be part of a pair. And the mode that we're going to use is just markers. And data equals trace. So just this trace, part of a list. And we're going to use this key value pair of a Python dictionary to pass it to the iplot. And let's run that. And there we can see the way that we created it by adding those values, that there's some sort of correlation between what we have at the bottom, age, and the salary on the left-hand side, the y-axis that we can see here. So those are quite small dots. We can really do something about that. So let's change these markers. So I'm going to have mode still being markers, but then for marker, we're going to pass a dictionary of values. So the dict function here in Python, so the size being 12 and the marker being this orange color with a bit of opacity there, only 90% of the opacity. And let's change the layout. So the way that I'm going to use layout here is again as a Python dictionary. So we're going to have title being correlation between female age and salary. The x-axis is the key, the value is another dictionary with a couple of key value pairs, title being age and zero line being false. And with the y-axis, title being salary and the zero line being false as well. And the iplot, the data is data and the layout is layout as per usual. There we go. So now we have an x-axis title here, a y-axis title. We have a title here at the top, correlation between female age and salary. And we see these much larger orange dots. And if I just hover on one, you can see that the value for that one was 1039 and the age was 34 that we can see at the bottom. We can change that, and now we can see them plotted, the hover there being 31 the age and 1021 being the salary, 0.161. So let's do more than one data set. So for that, I'm going to create two separate traces, and one being the female, one being male, and again it's age against salary. I think you know what's going on here now. Data will be the list of the two traces, and the data, I'm going to just pass the data that I've created here, this list of the two traces, to the data key value in my dictionary here, and we can plot that. So there we go, we've got female in orange and the male in this blue, and we can see all the values as we go up. We can see this beautiful correlation between age and salary there. So let's add a third variable in this 2D space, and that's what scatter plots are all about, and I can do that in a few ways. One is by marker size, and the other one is by marker color. So let's start with this marker color, and that's to introduce a color scale. And you can see all the color scales that are available, grays, and this and that and that and that and that, etc. We can use Portland. There's Portland there. So we're going to create a trace, and it's x equals female age, y equals female salary, mode being markers, the marker being a dict of the size of 10. The color is going to be the female debt, and the color scale is Portland. So we have age, salary, and debt all in the same 2D plot, and that's going to create a scale on the right hand side, a color scale, and we want that scale to be true. look at the layout, what we've done there. Let's do the iPlot. There we go. And now we've added this third variable because we've got age and salary, but this color is also going to be this color that we introduced here as the debt level. So down from 16 up here 28. So these red ones have more debt, say, than these blue markers here. So that's one way to introduce a third variable. The other one is just by way of what we would know as a bubble chart, actually. But that's just the marker size. So what we're going to do here is just change from female to male. And the marker is going to be the size of the marker is passed as a part of a dictionary here. And we give it a color. Let's have a look at this. So now we see that this debt is now the size of these. So the larger the size, the larger the debt. So that's one extra way of bringing in this third variable. So that means we can actually have 4 variables that we plot in 2D space because we can just combine the color scale and the size. So here I've made the size the debt and the color the tax, so that I have 4 variables actually drawn right here in my 2-dimensional scatter plot. And that's actually quite fantastic to do. So we've added this 4 variables just in this flat file by just looking at this bubble size, the marker size, and then this color scale. And you can see there the size was the debt and the scale here was the tax. So higher the tax value here, the more brown these values are. And we've again used earth. This time we've used earth just as the color scale that we have on the right hand side. So have a lot of fun with your scatter plots. You can really convey a lot of interesting information just using scatter plots. I'll see you in the next tutorial. Please remember to subscribe and hit the bell so that you can receive notification of all the tutorials that I do upload to YouTube. So welcome to this new tutorial. We're going to look at line charts, something that you might want to use quite often. So first cell, of course, we're going to just run our cascading style sheet. There we have a header 1 and a header 2 setting up our Plotly library. And as per usual, we're going to import iPlot and initialize the notebook mode. So let's just do that, initialize the notebook mode. And then we're going to import plotly.graphObjects, graph_objs as geo. And there we go. Let's create some data point values. I'm going to create 2 computer variables. They're going to be days and sales. And days going to go from Monday through to Sunday. And sales, I'm just going to have these 7 values, 11, 14, 11, 14, 10, 11, 10. And that's it. Let's run that to execute. And we now have our 2 computer variables. Let's just do a simple line chart. So to do a line chart, we're actually going to use the scatter. So scatter as in scatter plots. So what we're going to pass is just these 3 arguments, x being the days, y being the sales, but the mode just being lines. So our data is trace, and we're going to use this key value pair Python dictionary here to do the iPlot. And let's run that, and we see that we have the lines, and we go from 11 up to 14, down to 11, up to 14, down to 10, up to 11, and down to 10 for Sunday. So beautiful there. What we can also do is just to fill up the area under this curve, under the lines that we have here. So we're going to have fill, and we're going to fill to 0x. So whatever the lowest line here is, we're going to fill to there. The fill color, I'm using a hex code in this instance. My mode is still lines, and let's plot that. And we see it's just going to use the default color, and it's going to 0, meaning this bottom line of the y value here. So we're going to fill up everything below that. Now there are different line types that you can try. There's actually dash dot and dash dot. So let's do mode as lines again. And the line, we're going to pass to that a dictionary because it has these sub key words that it can use. So color, we're going to stick to this color. The width, we're going to do a width of 4. And the type, we're just going to do a dash. And what we're also going to do is just to lay out the x-axis, key value pair, key being x-axis, the value being another dictionary with a key value pair, 0 line being false. We don't want to have the 0 line at the bottom. And there we go. We see this orange color. We see it's quite thick with a 4, and everything is still there. We just changed this line type. Now we can also add some markers. So instead of the mode just being lines, we can have lines plus markers, and we're going to give the size to these markers. So marker, we're going to equal a dict with one of the arguments being size and the size being 16. And this time I'm going to add a layout. The layout I'm going to do as just as a Python dictionary here. So it's going to have a title and an x-axis. So the key value pair here is title, and the title sales for last week. But what you can see here, I've got some HTML code in here. So I for italics and close the italics. So we can even do that as far as this title is concerned. And the x-axis key, its value is another dictionary with a key value pair, the 0 line being false again. And then for iPlot, I'm just using this dictionary way to do it. And as I mentioned before, there's so many ways to do things in Plotly, which might make it confusing initially, but actually makes it much more powerful, and you can actually choose, what works for you. So there we go. We've added the sales for last week. So we've got this title, and we can see the last week is in italics. And now we've added these markers that might give it a bit more clarity as to what is going on here. Now we can also do some interpolation. These are just straight lines. So let's do a spline interpolation. So what we've got here is mode, again being lines plus markers, the marker having a size, but the line, we're going to do one of its arguments there being shape, and we're going to make the shape a spline. So let's run that, and there we go. We can see instead of these straight lines, we have the spline curve in between these values. We can also do vertical and then horizontal. So the shape is VH first, vertical, and then horizontal. So let's run that so that you can see. So what it will do from this value, it will go vertically first until we get to the level of the second one, and then go horizontal. So it's going to go vertical to the level of the next one and then go horizontal, as opposed to HV, which is horizontal and then vertical. So now it's going to go vertical to this line of the second one, and horizontal and then vertical up. So horizontal first and then vertical. So you can play with those two, and there's actually a few more ways that you can go about this. Filling of the gaps. So let's do that. Let's take the third value there for sales. Remember, it's actually fourth because it's Python and it comes from 0. And we're just going to make that value in the list being none. And if we were to plot this, we see that we have this gap. So there was nothing for Thursday, and this gap, there exists this gap now. And we can actually just fill in that gap by this connect gaps keyword in our scatter plot here, and everything else being exactly the same. What it'll do now is it'll just fill that gap beyond this data point, which does not exist. It's none now, and it'll just fill that gap. So you can see line charts, quite a bit of fun and quite a useful thing, something that we use quite often. And there we go, line charts or line plots. I'll see you in the next tutorial. So here we are in another tutorial. We're going to talk about the box and whisker plot, and it is a very common type of plot to use and quite informative. Now we're going to import the cascading style sheet, style.css, as we usually do, and let's set up our Plotly library here. So from plotly.offline, we import iPlot and initialize notebook mode, and we actually call that function init notebook mode so that we can plot directly inside of the Jupyter Notebook. And again, we're going to use high-level charts. The box plot is a high-level chart, so from plotly.graphObjects or graph_objs, we're going to import that as Go. So let's import numerical Python because we're going to use that, and we're just going to seed the pseudo-random number generator so that we can get the same random values every time. So I'm going to create 3 computer variables here. Let's just increase the screen size here so you can see properly. We have group A, group B, and the control group, and I'm going to draw 500 values each time. As you can see, the size argument here from a normal distribution with a mean of 100 in the first instance and a standard deviation of 10. So the keyword arguments there are LOC and scale, a mean of 110 and a standard deviation of 15, and a mean of 105 and a standard deviation of 20. So we're just creating these 3 lists or arrays at least of 500 numbers each. So let's do a simple box plot. Again, we're going to have a trace, and our high-level chart is this box. So it's go.box, and on the y-axis we want the groups. The data is just then a list of all the traces. We only have a single trace, and we use this key data pair, key value pair here in a dictionary just to do the iPlot. And there we go. And it's because we said y equals group A. So on the y-axis here we have all the levels. And that gives us this vertical box plots. So if I hover over there, we can see a maximum, we can see a minimum, we can see the whiskers, the upper and lower fences there. We can see the medium and the first and third quartile values there. We can also see these outliers that are beyond the whiskers, and I can actually hover over them and we can see those values as well. So let's just do more than one data set, and the way that we're going to do that is in a Pythonic way. So this is something new I haven't shown you before. Let's increase the size one more time so it's nice and clear. So I'm going to have this empty list here called trace, and I'm going to have values inside of a list, a Python list, group A, group B, and control group. Those are the arrays that I created above, and then groups, I'm going to have this list of strings, group A, group B, and group C. So I'm going to use a little for loop. So I'm going to say for I in range 0 to the length of the groups. So the groups here is 1, 2, 3. So it's going to go from 0 to 3, which in Python language means 0, 1, and 2. So it's going to loop through a 0 instance, a 1 instance, and a 2 instance. So I'm going to append to this trace empty list a box, and the y is going to be vals I. So the first one is vals 0. Val 0 is group A. So I'm going to say y equals group A. And the name equals the first one, or the 0th one here in this groups list. So there'll be group A. And my data is going to be a trace. Now I'm going to run through this 3 times. So I'm actually going to just have 3 traces. And this trace is a list. It's inside of square brackets. So I'm just going to have all of them there. So I hope you can see what's going on with this for loop. It's a Pythonic way of handling this. Instead of making 3 traces, I'm making one single, I'm doing it once in a for loop. So if I were to run that, well, let's just run our 3 values there, our 3 computer variables there, and then run our for loop. And now we can see we've got 3 traces named group A, group B, and group C, and we've plotted each of them, no problem. Now let's go through this again, and what we're going to say here, the only difference we're going to make is that we're going to do box plot equals outliers. So it's another argument that I'm adding to this box chart that I'm creating here. And although it's no different from what we've seen there, we've just explicitly said that we want these outliers now to be identified properly. I can also say, omit the outliers, and then these will disappear. They won't be shown here at all. Now, there are more than one ways of doing horizontal box plots, but the easiest way is just to change from the y-axis to the x-axis. So that's the only thing that I'm changing here, is to say that this must now be on the x-axis, and we see these values of my variables are now on the y-axis, making these box plots horizontal. No problem whatsoever. Now, instead of just these outliers, we can actually have all the box plots in there. And another argument I'm going to add here is box points, and I'm going to say all. I'm going to add a jitter of 0.2 and a point position of negative 1.5. Let me show you what that ends up being. There we go. It just shows all those 500 points in here. The jitter means it's not down a straight line, which means you usually can't see them. I'm making them left, right, left, right, left, right. There's a bit of jitter on the axis here, just so that they can see them all. And the point position is negative 1.5, so that means on the left, just move them slightly away from this little box plot that we have here. And now we see all the box points, all the values plotted there. I can add a mean. So another argument that I'm adding here is box mean, because remember what we see here in the middle is the median. We can also add the mean. Let's do that, and that'll draw this little horizontal line. I hope you can see it there, which, because we've taken this from normal distributions, there's not going to be much difference between the mean and the median for all 3 of these. We can also do the mean and the standard deviation by setting box mean equal to this SD. If we run that, we can see that we have the mean and we have the standard deviation out here on this dotted line. Let's play with the line colors. So nothing really changed. I'm going to introduce line, and that's a dict with a color, and we're going to make this black. 0, 0, 0. There we go. That's this black with a width of 1. We're not going to show the legends, so I can also take away the legend that we have here on the side. Let's run that, and there we see that everything is now in this grayscale, which perhaps is a better way to submit for publication. We can actually have a lot of control over what happens, and in this instance I'm making my line black again. My fill color is just, I'm going to iterate over with this for loop, and every time I'm going to change that. So that's a dark gray, a middle gray, and a lighter gray. So that is the fill color for this line, which I didn't specify there. And I'm also going to have the marker, the outliers. I'm going to specifically change the color of the outliers, and this is a bit of an orange, and I'm going to use this open circle. One of the key value pairs inside of this dictionary is symbol, and then also the size. So a lot of things that I can really play with. And if we look at this, this is actually quite beautiful. We have our dark gray, our middle gray, and our light gray, as I said there. And our outliers here are these 10-point sized open circles that are colored in orange. So really a lot that you can play with when dealing with these box plots. Here we are in another tutorial, and this time around we're going to look at subplots. How can we add a few more plots to the same figure? Let's run our first cell there, just importing our cascading style sheet. There we go. We're going to import iplot and init notebook mode from plotly.offline, and we're going to initialize this in notebook mode. I'm also going to import the high-level chart objects as go. And a new one, we're also going to import tools just from the Plotly library. Also importing numerical Python, and then we're going to seed the pseudo number generator just with a value of 1, 2, 3, 4. First of all, two plots on the same row. So I'm going to create two traces. They're both going to be scatter plots. Now we've created this data that we've seen before. Just a random integer chosen from a low of 20, a high of 65, and 100 of those. We're going to call that female age, then male age, female salary, male salary, and now we have det, and we have female tax equals male tax. Just a bunch of random data that we've created. We've looked at it before. So trace 0 is a scatter plot. On the y-axis, we're going to have the female salary. On the x-axis, I should say, and on the y-axis, female age. We have markers as the mode, so not lines or lines and markers, just markers. We're going to call this female, and the marker size is going to have a certain color and a certain size. We're going to have trace 1, also scatter, exactly the same thing. Here comes the new part. I'm going to create a figure object here, just going to call it fig, and that's going to be tools.make_subplots, and that's how you do those. And I want one row and two columns. If you think about it, if there's a single row and two columns, these plots are going to be next to each other. And I'm going to give each subplot a title. So I'm also going to use the argument subplot_titles, and I'm going to use this list of female and male. Now we need to append the traces to this figure. So we're going to say fig.append_trace. Trace 0 goes in position row 1, column 1, and trace 1 goes in row 1, column 2. So very easy to figure out how this is going to work. Fig.layout.update can also update a few more things, in this instance just a title. Let's run this and see what it looks like. And there we go, we see the two plots side by side. The subplot with the name drawn from the name in the trace, male on this side, the colors we've drawn in, and we see the plots side by side. So our first subplot. Now if we look at it, the y-axis here are exactly the same, 20 and 20, 30 and 30. We might as well just have one on the left hand side. So let's look at how to share that y-axis. Again, the two traces, nothing has changed. The subplots I've created, 1 row, 2 columns. Female and male, I've now added a new argument called shared underscore y-axis, ES. And I'm going to set that to true. Everything else is exactly the same. And if we run this, we see indeed that the axis on this right-hand side, the male side, has disappeared. We are now sharing the same y-axis. Okay, what about 2 rows in 1 column? So all we're going to do is just to shift this around. With make underscore subplots here, we're going to have 2 rows in 1 column. And we're going to say a shared x-axis. And you've got to think about this. These two traces that you are creating, or the number of traces that you're creating, they've got to have the same domain and range here. Otherwise, this might not make a lot of sense. So you've got to think about that. And if we run that, we see we have 2 rows in 1 column. And also we're sharing this single x-axis. And no matter where we are, we can still get all the data because this is Plotly. No matter where we hover, we're still going to get our data. So what about constraining the proportions? Now this one gets a bit more difficult. And we need to pay a bit of attention here. We're still going to create our trace. That's a scatter. But our trace, the second one we're creating here, trace 1, I'm going to put 2 new arguments. And that is x-axis equals x2 as a string and y-axis equals y2. Telling Plotly that this goes on a different axis altogether. Now we don't need to do that if we're not doing anything fancy as we've seen before. But here we want to do something. So I'm going to use a different way of creating the data. That's a Python list, trace 0 and trace 1. And I'm going to have a separate layout as we've had before in all the other tutorials that we've had. So that's go.layout. I'm still going to have a title. I'm going to have an x-axis. And I'm going to pass a dictionary to that. And that dictionary is a domain. And think about this x-axis going from 0 to 1. So 0 to 100% of the width of what you have available. And here in the domain we're saying use the leftmost 70% of the area of our figure for our first trace. So the x-axis goes from 0 to 0.7. X-axis 2, remember, which comes in this one here, we said x-axis 2 equals x2. So x-axis 2 goes from 80% to 100%. So the 20% on the right-hand side. And we just have to say that y-axis 2, so the second plot is anchored to x2. So it will know that it has to anchor this second y-axis to this part that we've specified up here. So it won't mess it about and put it in the first one. And then fig equals go.figure. So we've done it this way around. Remember, you could just say iplot and use the standard dictionary format that we've seen before. So let's run that, and now we can see we're constraining this right-hand side to the last 80% and 70% on this side. And this y-axis was told to fit with this little one on the right-hand side. Okay, let's customize the axis a little bit more. Here's a long one for you. We're just creating these 4 traces. They're all histograms. We're going to make a subplot, and we're going to say we want 2 rows and 2 columns. We give a name to each of those. You don't have to, but we're going to call it figure A, B, C, and D. And I append each of those to the position that I want. Row 1, column 1, row 1, column 2, row 2, column 1, row 2, column 2. So it's always row first and then column. And it's got to line up with what you specified up here. So fig.layout, x-axis 1 update its title, x-axis 2 update its title, x-axis 3 and 4. And then y-axis 1, 2, 3, 4. These have all got to line up with the number of plots you've created there. And I can give each of the axes its own separate title. We're just going to update with a main title. And one new thing here, I'm just going to say show legend equals false, because I'm building in all the detail into each of these little subplots. Let's run that. And there we go. We get our 4 histograms that we created here, figure A, B, C, D. They've all got the axes. They're all nicely labeled. No problem whatsoever. So you can see female age and frequency, male age and frequency, female salary frequency, male salary frequency. So I can individually name each of these axes so we know what it's all about. Let's just look lastly at an odd pairing. So I'm going to introduce a new argument here to the tools.make subplots. I want 2 rows and 2 columns. But you can see I've only listed 3 things here. That's because I want the bottom two to be combined and I want it to make up one single long plot. So 2 at the top. The first row will have 2 columns. The second row just a single column. So it's got to go all the way across. So I've got to introduce the specs. Now look at it. We see it's a list. And it's a list in 2 parts. The first part is going to be for this first row, just showing the 2 there. And the second one, we're going to say the column spans both of the columns. And then none, because it is just the full thing that we want, because we only want these 3 figures. Otherwise, everything is exactly the same as we've seen before. And there we go. See what we did? It spans the whole, this third one here spans this whole row on both sides. So look and play around with this specs argument, but you can clearly see how that was built up for the 2 rows. And we want those 2 in the first row, but we want a single one in the second row there. And that is subplots. Have some fun enjoying your subplots. It really helps to be able to do subplots, and especially if you're creating reports or manuscripts for publication, to have more than one element in the same plot. Remember to subscribe and hit that like button if you want to. Hit the notification button though, that's important, so that you can get notified if new material is released. Remember that you can also find all of these files on GitHub. A link is in the description below. Speak to you next time. In this tutorial, I want to show you how easy it is to import images into a collaboratory notebook. So I'm on my Google Drive here. I've navigated to where I keep my YouTube tutorials, and I'm going to simply say New, scroll down to More, and then Collaboratory. After a few seconds, it opens a Jupyter notebook for me. Let's change the name of this notebook. I'm just going to highlight Untitled 0, and we're going to say Display Images as the title for our Jupyter notebook. So we've got our first cell here, and I'm going to import 2 things. I'm going to say from google.colab, we're going to say import files. Very important, because we're going to use that files to actually import our image. And then to display the image in a notebook, I'm going to say from ipython.display import image. So those 2 lines of code, and we're going to use them, as I say, to import our image and then to display our image. We'll add a new code cell, and in here we're going to create a computer variable called uploaded, and that is going to be files.upload. Files.upload, so we're going to call this upload. And we can now choose a file. It's going to open the browser that is pertinent to our operating system. And I'm going to choose from one of those files. It's going to upload now, as you can see, 0%, 18%, 35%. And there you go, 100%. Now you'll notice it says saving krglogo.lightpng to krglogo.light space 2. So I've got 2 other notebooks open, and I've already loaded these logos there, and an instance of that will exist. And it is this name that I now have to use to display. Whatever it was called during the upload is what I'm now going to use. So let's use image, and inside of image we're now going to use krg logo light and then 2.png. And I just want to add one more argument, because it's quite a large image that I'm importing here. So it's width. Let's set the width here, in my case, to 1200. Let's run that. And there we go. We can see the logo being displayed there beautifully. So that is how you import an image and how you display an image in a collaboratory Jupyter notebook. In this tutorial, I want to talk to you about using Plotly inside of Google's Collaboratory. So I went to my Google Drive and I've opened a new Jupyter notebook as a Collaboratory file here. I've given it a name and imported my research group's image. So let's talk about importing or using Plotly inside of Colaboratory. Now, it is one of the libraries that has already been loaded. So it is no problem just to use Plotly. You can just import it as you would usually do. So we're going to import NumPy as NP. From SciPy, I'm going to import stats just so that we can simulate some data. And then from plotly.offline, I'm going to import iplot and init notebook mode. And I'm also going to import plotly.graphObjects as geo. Now, notice carefully, I'm not initializing the notebook mode right now. So to run this, we click on the little arrow to the left-hand side, and that cell executes. You'll notice on the top right-hand corner, it has connected, and it is connected to the Google engine as far as Python's concerned. Now you can pause the video here and copy this function. You've got to create a function that you then call in every cell that you want to use Plotly in. So I've called it configure_plotly_browser_state, and we're going to import IPython, and we're going to write this display script. As I said, you can just copy and paste it. Let's run. And now let's get to simulating some data. So I'm just going to seed the pseudo-random number generator there with the number 1. And I'm going to create a computer variable called WCC, for instance, white cell count. And I'm going to take that from a normal distribution with a mean of 15, standard deviation of 3, and I want 1,000 of these data point values. And now we can plot. Now, as I mentioned here, it's required in every cell that you want to run a Plotly graph in. So you've got to use these 2 lines of code. So we're going to call this function, and then we're going to initialize the notebook mode with connected equal false. So you can copy and paste that as well. That has got to go in every cell. And now it's just normal Plotly. I'm going to use trace 0 as is the norm, go.histogram. My x-axis is going to be the white cell count. My data object is going to hold the trace as its single list element. And I'm just going to make the plot look a bit better by introducing some layout. And then I can call iplot, and I use, as always, the dictionary format. So data being data and layout being layout. Let's run that. And there you go. We have a Plotly graph right inside of a Colaboratory Python notebook. Beautiful. So copy and paste the definition, and remember to call that the function and to call that function in every cell that you are going to use to create a Plotly graph.